Thank you, sir. Oh, I didn't see you there. Today we're going to be learning about many different structures.
I can't even begin to understand. And when's that gonna be done, man? Hold up.
I've been in the kitchen, whipping. I've been.
So, here we have a Lewis structure, a partially condensed structure, a condensed structure, and a molecular structure. Now, if we just look at these structures, what do we see? Well, we see differences. You can see here that everything is drawn out. The valence electrons are drawn on this oxygen. All the bonds are drawn. Here we see that bonds are drawn, but not with hydrogens. Those are implied. So the difference between a Lewis structure and a partially condensed structure is that the hydrogen bonds are not drawn. Take a moment to notice those differences. Now let's move on. We have our condensed structure. Our condensed structure actually doesn't show the bonds explicitly. It's implied. And here we have our molecular structure. How did we go from the condensed structure to the molecular structure? I'll give you 5 seconds to try to figure it out. Well, let's see. So we have a CH3, 2, and then a CHOH. CH3, 2, that means we have 2 carbons, 6 hydrogens. Another carbon, that makes 3. Another hydrogen, 7, we're not there yet. An oxygen, oh, there's our oxygen. And a final hydrogen. Isn't it amazing how simple chemistry is sometimes? So, as you can see, what are the differences in these two structures? Which one is the skeleton structure? Well, that is the skeleton structure. We can see that this is a bit like a Lewis structure, right? It shows the valence electrons on the oxygen. And this, our different friend, is a skeleton structure. Now the skeleton structure has the carbons implied. Look at the differences. The hydrogens are also implied. Right here we would have a carbon. Right here we would have a carbon. Right here we would have a carbon. And right here we would have a carbon. As you can see, the carbons are implied. So are the hydrogens to complete the octet. Now, skeleton structures can be used with basically any type of carbon chain. We see here we have pentane. That is the skeleton structure for pentane. You can see how many carbons are there in pentane. Well, if you remember from our nomenclature video, pent is the prefix for 5. And ane completes our name. So let's count. 1, 2, 3, 4, 5. So we know this is a skeleton structure, and this is how you represent a double bond in a skeleton structure. But how do you represent a triple bond? It's right here. That's how you do it. How do you represent a quadruple bond? Silly goose. There are no quadruple bonds. So now, this is how we represent a skeleton structure in 3D. As you can see, this is obviously in 2D. But since I, frankly, don't understand this skeleton structure, I'm going to have my Icelandic associate, Kevin, come in. Now, Kevin, make an appearance, please.
The wedge means that it's going out of the page, and then the dash means it's going in the page.
Chefing it. Mix it with my left hand. Water whipping and I'm stirring. Y'all want beef and I'ma serve it. Water whipping and I'm stirring. Y'all want beef and I'ma serve it.